Hey everyone, today we are going to discuss about operations on heap tree. First of all, if you want to learn about the operations, let us discuss about the heap trees. Heap trees are the specialized binary trees. There are two types of heap trees, min heap tree and max heap tree. Let us discuss about heap trees in a further manner. If you want to learn about more about heap trees, let us discuss about binary trees. Binary trees are one of the trees in which there are each node consists of at most of two children, except for leaf node, which is the bottom node of the tree. Each and every node consists of two children. This property is satisfied up to every level of the heap binary tree except for pair for 0 which is also known as node level, otherwise the bottommost level which is known as leaf node level. As we can see, here is the example. Here one is the, let me just check here. Here let's see the example of the binary tree. Here the parent node 1 is the parent node of 2 comma 3, where the 2 comma 3 are the two children of a parent node. That means the parent node consists of only two elements, two children, 2 comma 3. As we can see, the 2, which is the children of the parent node, also consist of at most two children, which are the leaf nodes 4 and 5. That is, we can say that the binary trees or the trees which consist in which the parent node consists of at most of two children, except for leaf nodes. Next, we will go for the next slide. After discussing the binary trees, we will move on to the heap trees. Heap trees, as we can say, heap trees consist of two. Heap tree is a specialized tree in binary tree. It consists of two types, max heap tree and min heap tree. As let's just discuss about max heap trees. In max heap trees, the parent node is the largest value in the tree. As we can see in the example here, parent node 17 is the largest element in all of the tree. So we can say that in each level, parent node is the largest value. Parent node is the largest value of the tree of that level. And we can see here 6 is the smallest and 10 is also smallest, whose parent is 15, which is the largest of 10 and 16. This property is hold for all the levels in the tree. This is known as a min max heap tree. Let's just move on to our topic, operations on max heap tree. In max heap tree, we can conduct four types of operations. Insert. Insert is the type of operation in which we can insert a node or a element into the max heap tree, in which a position can be in the position where the max heap property will be applicable. And next is extract the max. This property is this property of the max heap tree removes the maximum element from the max heap tree and returns that maximum element to us. The max heap tree property also maintained after removing that element. Let's just move on to the third operation, increase the key. Increase the value of a existing element in the max heap tree is known as increase the key. This property is also maintained even after incrementing the value of the element in the max heap tree. Deletion operation. Deletion operation is a part of the operations on max heap tree in which we can delete a node or an element from a max heap tree and maintain that principle or property of that max heap tree up to the mark. Let's just this implementation of this program very depend upon the programming language we uses, and we can import the different types of libraries according to our programming language to implement these operations on max heap tree. Let's just discuss about insertion and deletion. Insertion operation in the max heap tree. Insertion operation is a part of the operations on max heap tree in which we can insert a new node or a new element into the max heap tree which uh, which upholds the property of the max heap tree. To insert a new element, we will check whether it is the first element in the max heap tree or not. If it is the first element, we make that element as the parent node, and we will choose that max heap tree. If it is not, we will check the appropriate position for that element to be inserted into the max heap tree, and further we will insert that element into the max heap tree at the appropriate position. Once the new node will be inserted, we will update the parent nodes and parent pointers over the nodes of the tree into the appropriate positions. This will this example will give us some details on the insertion in maxi tree. First of all, here is the leaf node 3, which is the child node of parent node 10. If we want to insert 15, we will try to insert it here, or according to this, we will insert the value at the leaf node part. But to uphold the maxi tree operation, we will swap the 3 and 15 values further. And to uphold as the parent node 10 is the smallest than the 15, we will update the parent node of the tree as 15. Thus we can insert, by this way, we can insert the elements into the maxi tree. Deletion of a max heap tree. Deletion of a max heap tree involves maintaining the max heap property while removing the specified element. There are further 4 steps in the deleting of a max heap tree. First of all, we need to locate the element to be deleted from in the max heap tree. Identify that element and point out with a pointer. Next, we will replace the last inserted node with that element. And because it is easy to remove the last inserted node than removing the node at a particular point, so we will replace that with the last inserted node. Finally, the last inserted node will be removed, that is the previously swapped selected node will be deleted by using the third step in the deletion of the max heap tree. Finally, we will check whether the max heap tree property is applicable to our binary heap tree or not. If it is not applicable, we will swap the variables according to that property. Let's see the example here. Here I want to remove the 10, which is the parent node of the our binary heap tree, max heap tree. So I will swap it with 1, which is the last inserted node, and we will have the parent node 10 deleting node. Here first of all, I located the 10, and second step, I swapped the 10 with the last inserted node, and 10 will be here. And finally, I remove that 10. I remove that 10, and I will check in third step and fourth step, I will check whether the max heap tree property is applicable to our binary heap tree or not. Here, 1 is the least element than the right child node of 8. So I swapped 1. So I swapped 1 with 8, and 8 with 1. And here I can see that the parent node in the level 1, which is the smaller than the left child node 2. So I again swapped that to maintain the max heap property. So finally I get this node by deleting the parent node 10. Here we can see every element is smaller than 8, and each parent node is larger than those of their child nodes. So we can revise that our PPT. First of all, I checked. I explained about binary heap trees. What is a heap tree? It is a specialized binary tree, and types of heap trees, min heap and max heap. And we discussed about the binary trees. Binary trees are the trees in which the each and every parent node consists of at most of 2 children. That is applicable in every level. and some part of and some special case is the heap trees. And we discuss the operations on max heap trees like insertion, deletion, extract number, and increment of a number. And we discussed about insertion and its properties, and deletion and its properties. So thank you.